And this is what we got for today, ladies and gentlemen. We got chapter 4.6, polynomial and rational inequalities. Today we're going to, again, solve these inequalities, both polynomial and rational, and we're going to do that graphically with examples 1 and 2. And then on the back side, we're going to do some algebra, okay? Now, the nice thing is we've done this already in chapter 3.5 where we did quadratics, okay? So I don't want to like waste our time, and we have shortened periods anyway. So I'm just going to give you a reminder. Anytime that we are doing inequalities, visually, if I see greater than or greater than equal to 0, then we are looking where it is above the x-axis. Okay, another way to say that is where the y values are positive. Versus if I see that it's less than or equal to 0, one of those two, then we are looking where it's below the x-axis, where its y values become negative. Okay. So we're going to look at examples 1 and 2. All right. So we got a polynomial and a rational. We should know this little continuous roller coaster ride is a poly. And this one's the dirty rat. That's a rational. All right. So we got a polynomial function, continuous graph, domain is all reals. This guy, I can totally tell that they have the, what are these lines called again, where you're getting closer and closer to but never touch? What are those things called? Use your microphone. What are those things called? Asymptotes. Watch your mouth. Yes, those are asymptotes. Okay, so we definitely see we have asymptotes. Those are the rationals. That's where we have undefined values. Okay. All right, so let's take a look at example 1. I've got f of x. I'm going to do f of x in blue here. So f of x starts here and goes up, crosses, it touches, and goes back up. Okay. And then 0, y equals 0 is this horizontal line, the x-axis. Okay. Well, we want to look at this graph and identify where it's greater than 0. And we just talked about where it's greater than 0 is where it's above the x-axis. So basically what I'm going to do is I'm going to follow my graph and just kind of highlight where it's above. So I start, it's below the red line, the x-axis, below, on, above, it's above, and then on, and then above. Okay? Well, on a number line, what this would look like, I have a 0 right here at -3, and I have a 0 that touches right there at 2. Okay? So what I see is that from -infinity to -3, it's all below. And then at -3, all the way to 2, it's highlighted, it's shaded, it's above. And then at 2 again, to infinity, it's above. So basically all my shading would be all this. Now, it's where it's greater than 0, not equal to. So we don't include -3 and 2. We got to put parentheses there. If it was a bar there, then we would have brackets. And we would be inclusive. And in fact, we'd go all the way from -3 to infinity, but it's not. So I have -3 to 2, parentheses around that, interval notation, union 2, and it goes all the way to infinity. Okay? So we can, that's interval notation. And tonight on homework, you guys have some My Math Lab, and I try to get some multiple choice ones so you don't have to type all that stuff in. I know that gets tedious. So basically, you got to look at it and identify, and then select, is it A, B, C, or D? Okay. Okay. All right. Any questions on that one, y'all? So final answer, -3 to 2, union or, and then 2 to infinity would be my interval notation. All right, so I look at the next one. Example 2, I got f of x, we'll do in blue. So f of x is this rational function, getting really close to these asymptotes. And then it's where f of x is less than or equal to 0. So 0, again, is the x-axis, so I'll color that. One of the questions I had earlier today is, well, this kind of looks like an asymptote at y equals 0. And I said it is. And then somebody said, well, if it's an asymptote, why does it cross the asymptote? By definition, horizontal asymptotes can cross for small values of x. It's the large values of x. So as x approaches infinity, it will get closer and closer to, but never touch the horizontal asymptote. It is okay for a graph to cross a horizontal asymptote for small values of x, but the large ones, you cannot, it will not cross. Okay, hopefully that makes sense. So that's the definition of a horizontal asymptote. All right, what are we looking for? You guys tell me. I want less than or equal to 0. What type of numbers are less than or equal to 0? Those above the x-axis or below the x-axis? Above or below? Shout it out. Below, is that what I heard? All right, so less than is below. Now, because it's equal to, I also want on the x-axis. Okay? So I take a look, and from the left, below, 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 down there. And then the graph stops at -2, and then starts up here. Above, 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 on, so I want that. Below, 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 and then above, 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 above. Okay? So if I was looking at a number line, I have an asymptote at -2, I have a 0 at 1, and I have another asymptote at 2. My shading would be over here, and from 1 to 2 is all below. Okay? Now, when we look at this and we visualize it, we want to know where f of x is below and on the red one. Well, a lot of people put brackets right here at -2. But if you look at -2, the graph is neither above, below, or on the red line. There's in fact nothing going on here. And that's because that's an undefined value. You can't have that equal to -2 or 2 because that is an asymptote. That is a restriction in our domain. So when I look at this, 2 and -2 get parentheses. Okay? And that's because those are asymptotes. So asymptotes, those undefined values, okay, never, ever get brackets. They always have to be parentheses. Okay? Now this is going to be a question that's going to be on your quiz. And it's going to separate the people that are getting it right and people that are getting wrong. Okay, so do whatever you need to do. Highlight this. Okay, highlight these asymptotes so you don't make that mistake. But asymptotes never, ever get brackets, always parentheses. But it's on at this 1, 0, at this 1. That is a 0, the function. That guy gets a bracket. Any questions on why 2 and -2 are getting parentheses? Are you guys okay with that? Any questions? So from left to right, this is negative infinity. It goes all the way to -2. Parenthesis, union or, bracket on 1, all the way to 2. Okay, so negative infinity, -2, parenthesis, union or, bracket on 1, comma 2. Undefined asymptotes never, ever get brackets. How are we doing visually, guys? Are we okay with this? Any questions? Give me a thumb where we're at, guys. Give me a thumb. Thumbs up. Mr. Gotsch. Thumbs up. Thumbs up. All right, all right. Thanks, guys. All right, let's move on to the algebra part. I'm just going to do, of the 4 back here, I'm going to do 3 of them. Okay, and I'm actually going to make this first one even easier. Okay. We don't need to talk about difference in sum of cubes today, so just kind of cross this one out and rewrite it so it's just x to the 3rd is greater than x. So I just changed the exponent to a 3 instead of a 4. Make that change, it's going to be easier for us. Okay. All right, so these rules, these steps to solve polynomial and rational inequalities is exactly what we had in chapter 3.5. The first thing is get your function greater than or less than 0. So again, get your stuff greater than 0 or less than 0. So get everything on one side. So I've got x raised to the 3rd is greater than x. The first thing I got to do is subtract this x over. Okay. Then we're going to find, step 2 says find the zeros and undefined values. Well, this is a polynomial. There is no undefined values. That's the undefineds are only for rationals. So I got to find the zeros, and to find the zeros, I got to try factor in here. Okay, so I've got x cubed minus x. We're going to go ahead and factor this guy. How do you guys factor it? What can I do? First thing I can look for. What do you guys think? Hank, Laura, Josh, Joe, Ariel, Braden, what do you guys think? Raman. How do I start factoring this guy?
You can take x out of both.
Yeah, take an x out. Perfect. GCF. I've got x squared minus 1. Now, x squared minus 1 factors further. How do you factor x squared minus 1? So Emily helped us out with this one. Who's going to help us out on the next one? Nice job, Em. X squared minus 1. Factor it for me. Teach me how to factor. What do you got, Broderick? Do a little factor, Anna. Melody.
X plus 1, x minus
1. Fantastic. X plus 1, x minus 1. Okay. Then I want my zeros. My zeros is what makes each thing 0. So if you need to set it equal to 0, my zeros would be 0 for x. X plus 1, I would subtract it, so it's negative 1. X minus 1 would be plus 1. So plus or minus 1 and 0 are my zeros. Okay. So then use your numbers in step 2 to create your intervals. So I'm going to put this on a number line. So I got negative 1, I got 0 and 1. Okay. Then we're going to test for pluses and minuses again from the front. If I have greater than equal to 0, that's above. That's our pluses. And if I have less than or equal to 0, that's below. Below. That's our minuses. Okay. Now, you guys can do this in your head. Totally fine. You can take a number over here like -2, plug that in your head and simplify it. Some people don't follow me when I'm doing that, so I'm just going to use my calculator. Okay. So I'm going to type in this guy here, x cubed minus x, just the original function. So x raised to the 3rd minus big minus sign above the addition, x. And then I'm just going to zoom 6 this thing. Okay. All right, I'm going to plug a number in to the left in this region on the left-hand side of -1, so like -2 or -3 or -4. I'm going to go second trace value -2. And I got a negative, right? It's below the x-axis. Those are all negative values. So this region is negative. Okay. Then I need a number between -1 and 0. Well, what's a number that I can plug in that's between -1 and 0? What do you guys got? Give me a number between -1 and 0. -0.5. So it's a decimal. That's okay. Thank you, Joey. That gives me a positive 0.375. So again, that's a positive region. No matter what decimal between -1 and 0, that will be above the x-axis. And then I can plug in like 0.5 here between 0 and 1. So 0.5, that's -3.75. So that's a negative region. And then pick any number to the right of 1, and I can see that's going to be positive. I plug in 2, that's positive. Plug in 3, that's positive. It doesn't matter what you plug in, just as long as it's in the right region. That's a positive one. Okay. Now, it just so happens that this one alternates negative, positive, but it won't always do that. And that's why I have the next example to show you when those don't alternate. Well, I want to do some shading, and the shading is based on this guy right here. If it's greater than 0, it's above. That's the pluses. So I want my pluses. I want above. Okay, so all my shading is here and here. And then from there, these are not equal to, so it's all parentheses. Okay. So this is how you do it algebraically. My final answer in interval notation would be -1 to 0, parentheses around those. Union or, I don't see it until 1 to infinity. So final answer. So shaded between -1 and 0, it's above the x-axis, and 1 to infinity, it's above. And again, you can use your calculator. You can do all of this plus minus in your head. Totally fine. It's whatever you want to do. All right. Now, when I take a look at the next one, example 4, I like this one already because I don't have to do any factoring. So when I take a look, it's already factored for me. It looks like this guy already. I'm ready for my zeros. So my zeros is what makes those quantities equal to 0. So I would get -3. You don't have to write this, but it helps. You have a multiplicity of 2. Well, anytime I have an even multiplicity, I know that's a touch. So that means is it's going to come down, touch, and come back up. So it's either going to be above on both sides, or it's going to come, touch, and go back down. So it's going to be minus. So you'll have to see what's going on with that 0. This is an example where it doesn't just alternate minus, plus, minus, plus. It could go plus, plus, minus. It could go minus, minus, plus. So you got to look. Okay. The next 0 I have is 1, and the other one I have is 4. Okay. So I have my zeros. I put that on a number line. Here's -3, 1, and 4. Now again, I like just put in a calculator. I think it helps you guys plug it in easily. So I'm going to plug it in just like I see it. I got parentheses above the 8 and the 9. So I got parentheses x plus 3, close it. That's squared. Parentheses x, big minus sign above the addition, 1. Parentheses x, big minus over 4, -4. So I'm literally typing in like I see it. X plus 3 quantity squared, the quantity of x minus 1, and the next quantity of x minus 4. Zoom 6. Now, if I was in chapter 4.1 and 4.2 and I needed to graph this thing, I would change my y mins and maxes. I don't really need to do that, so I'm just going to kind of start and know that it is a quadratic. It would come up, come back down. Again, don't need this, but it helps visualize what's going on a little bit. So what I want to do is I just want to use my second trace value and figure out are these pluses or minuses. Okay, so again, remember -3 is a touch. you can see on both sides it's above, right? If I go second trace value and plug in something to the left of -3, like -4, I get a positive 40. So that's a positive. And something between -3 and 1, that's all above. So if I plug in like 0, I got positive 36. So you can see it does not alternate. It stays positive, positive there. Then I choose a number between 1 and 4, like 2 or 3. So I got 2. That gives me a -50. That's a negative region. And a number to the right of 4 would be like 5 or 6 or 7. Just plug in 5, and I got a positive 256. Okay. All right, so what type of numbers am I looking for, guys? What type of numbers are less than or equal to 0? What do you guys want? What type of numbers are less than or equal to 0? Shout them out.
Negative numbers.
Yeah, those negatives, right? So I'm looking for the negative region. I'm looking to see where it's below the x-axis. And the equal to, I'm asking you, where is it on the x-axis? Okay. So as I take a look, right here, it's negative, right? It's on the x-axis. That's inclusive here and here. Now in MyMathLab, if you type in bracket 1 for bracket, you're going to get it wrong. Okay? Does anybody know why this is almost right? We almost have it like 99% right. Look at your graph. We got all this. That's where it's below and on, right? It's on there and there. Do you see where it's below or on the x-axis anywhere else visually? What do you guys think? Do you see it below or on the x-axis anywhere else? Yeah, right here at -3. Isn't it on the x-axis? Okay, so we have to include that. I'm going to darken that guy in. Okay, so we would have to include that, and the way to do that is just a bracket -3 bracket, and then a union between them. So -3 has to be included in our solution set because that's where it's on. If it just said less than 0, then it would just be parenthesis 1 to 4 parenthesis. Okay, so that one's a little tricky. I wanted to include that in our notes just in case we didn't see that. Okay. All right. How we doing, y'all? Can we handle one more before we get out of here? You guys up for one more here? One more rational? All right, here we go. Last one, ladies and gentlemen. Here we go. Okay. So number 5, as I take a look at number 5, I've got a rational function. I've got x minus 5 over x plus 1. The nice thing is there's nothing I got to do. It's ready to go. I can find my zeros and my undefined value. Okay. Just a reminder, zeros, ZZ top, zeros are found on the top. Z, that's a Z there. My zeros are found on top, and then U and D's, my undefineds, are on the bottom. That is your domain, okay? U and D is undefined. So your undefines are found on the bottom. So if I take a look, the 0, what makes x minus 5 0 is 5. And then the undefined value is what's on the bottom that makes it 0. That's -1. Okay, so very similar to what we just did with polys. I put -1 and I put 5 on my number line. You People like to graph these. Remember, if you got a TI-83, use parentheses here and here. Okay, if you got the 84, you can do alpha y equals and do number 1. Whatever you want. I'm going to use parentheses for my 83 peeps. I got parentheses x minus, big minus sign, 5, close it, divided by parentheses x plus 1, close it. Okay, so I'm going to type it in, the quantity of x minus 5 divided by quantity of x plus 1. Make sure you use parentheses. I graph it. And again, -1, we can totally tell at -1, there's an asymptote there. Right? All right, so we are looking to find out where this guy is, again, less than or equal to 0. This is telling me where to shade. Less than or equal to, those are the negatives, right? That's where it is below or on the x-axis. On because it's equal to. So we take a look. Type in a number to the left of -1. We say -1, second trace value would be like -2 or -3 or -4. That's clearly above, so that's a positive region. We don't want that. Then I do like something to the right between -1 and 5 would be like 0. So 0, -5, that's a negative region. That's definitely below. If I typed in 5, that's definitely on. That's at 0, 5, 0. And if I typed in 6, that's just slightly above. That's at positive 0.142. So that's a positive region to the right of 5. All right, I take a look. Below is the minuses. That's right there. Now the trick on this one, who gets a bracket and who doesn't? Who doesn't get brackets from before? Who gets a bracket and who doesn't? Does -1 or 5 get the bracket?
5.
Yeah, 5 gets the bracket. Very good. So this is a 0. That guy gets the bracket because it's equal to, it's on the x-axis. But -1 is undefined. Okay, so again, asymptotes, which are again UNDs, undefines, never get brackets. Again, star that up. Highlight it if you're a highlighting guy or gal. I am. Yeah, this guy. That guy never, ever will get a bracket. Okay, they're either both parentheses or if it's equal to, then the 0 gets the bracket. The undefined, the asymptote does not. So final answer, -1 to 5 bracket. Parenthesis on -1. That's where it's below or on the x-axis. All right, ladies and gentlemen, that's all I'm going to give you. I don't, I think this is good enough for what we need it for. This, you can do this one. It's just getting common denominators. I feel like it's Corona time. I'm trying to make this as painless as possible for you guys. So I've tried to give you some easier ones. Okay, if you do see one of these on homework, we can always go over it tomorrow. Okay.